Okay, so I asked you guys to have your homework out on page 35. Just to review that you guys are good with what we were doing yesterday. This was the homework that was assigned. So just to start off with, the first problem that you had to do, the 16 was the dry bulb. The wet bulb was 9. So what's the difference? How do we find difference? Subtract. So what is the difference between 16 and 9? That is 7. I want to reiterate, guys, don't do math in your head. Because if you mess up and say the difference is 6 or 4 or 10, then you're going to get the whole problem wrong. And that's not the earth science part that you're getting wrong. That's just subtracting. So again, we have a dry bulb of 16. So you find 16. And then you use the difference, which is on the top. So 7. So we do 16 over to 7. 16 and 7. And did you get 1 for that? You did, then you got it correct. That's the dew point. So we'll keep going with this. Then I asked you to find the relative humidity of those exact same ones. So you do the next chart over, which is the relative, or the next chart down, I should say. That's the relative humidity. So again, you use the dry bulb of 16 and you go over to 7 right there, 37. Everybody good? Okay. How about now for the next one, you only had to do every other, remember? So the next one down is the 4. So I have 4 for the dry bulb, and this time I told you the difference. So how do we find the wet bulb? 4, no. Oh, I guess, okay.
4 plus 0.
Okay, here's what I was just gonna say 4 minus what gives you 4? 4 minus 0 gives you 4. So now that's filled in. So we have the 4, the 0, and the 4. Now we can use the dew point chart. Make sure you're always using the right chart. If you want dew point, you got to use the dew point. So when you do this again, you find 4 for the dry bulb. It just so happens that 4 is also the difference, and you should have gotten a dew point of -7.
Yeah, I got that one.
You got that? All right, awesome. -7. And then when you did the relative humidity, hopefully you had 42.
Yeah, I got that.
Good. Now the next one's a little sketchy. Is that the one we did together? The 26 one? Or did we do the 28 one? Okay, so 26, it's the same idea as the one we did yesterday, but this time they only gave you the 26, which is the dry bulb, and they gave you the dew point temperature. So like I described yesterday, you got to work with what they gave you. So they gave us a dry bulb and a dew point. Which chart should we use then to find all the rest of the stuff? Got to start with the dew point. So they gave us 26. And then they gave us a dew point. Remember, these numbers in here are the dew point. So if I take 26 and I scroll through, oh, what am I looking for? 6. They told us the dew point is 6. So there we go. There is 6 of a dew point. Where'd that go? Right. So then you also now know the difference is 11. So like Zach said, so fill that in as a difference of 11. Right, so we know 26 minus something equals 11. 26 minus 15 equals 11. And then what do I do to find the relative humidity?
Yes, use 26 and 11.
26 and 11 on the relative humidity chart. 26 and 11, and you should have got a dew point or a relative humidity of 28%. Everybody get that?
Yeah.
Yeah, that sounded a little sketchy. Did you really?
I know.
No, what'd you get? Or did you leave it blank? It's the 26 was the one out front.
Relative humidity? 28.
Okay, good. You did get it. All right, then like we said, I'm pretty sure we did the 28 one together. So that would have been a wet bulb of 17, a difference of 11. We found a dew point of 9 in that case.
Yeah.
Now the next one was blank out front. So we want dry bulb, but this time they gave us a wet bulb and a difference. So if we had something minus 16 gives us 2. 18. So Sarah wasn't here, so she said 14. Well, what's wrong with 14? How, because she's not wrong. 16 minus 14 is 2. Yeah, dry bulb always has to be higher. Because the dry bulb is measuring the actual classroom or the actual wherever you're measuring. And the wet bulb measures how the temperature after it's been cooled by evaporation. So the wet bulb will either be the same as the dry bulb or always colder. So that's how you know dry bulb has to be bigger or the same as the wet bulb. So 18 minus 16 gives us 2. What'd you get then as your dew point? 15. And your relative humidity? 81.
I have it.
Good. Now this time, again, you got to work with what they gave you. We only had a difference and a relative humidity. So which chart should I use? Got to use the relative humidity. So they gave us a difference of 5. That's up here, a difference of 5 and a relative humidity, I'm sorry, I got lost, of 58. So scroll down the difference of 5 until you find 58 right there. Now that I found 58, what else do I know now? I know the dry bulb. Follow that over. I now know the dry bulb was 20. Yep, so 20 minus 15 gives you 5. And now how do I find dew point? I use the dew point chart and I use the dry bulb of 20 and I go over to 5 and I got 12. How about you guys? Good. The 17 one, 17 minus 13 is 4, so that's the difference. And you should have gotten a dew point of 10 and a relative humidity of 63. Good? And the last one, 5 minus what gives you 2? 5 minus 3 gives you 2, which should give you a dew point of 0 and a relative humidity of 71. So here are all of those answers. Did anybody need me to go through any of them again? Okay. You kind of comfortable with that? I want to talk about one thing, and you guys must have figured it out, or did we even talk about it yesterday? How'd you get this 17 one? The reason I'm asking is, why am I asking? You guys know? 17's not there. Did we talk about this yesterday?
Yeah, you would. Yeah.
Oh, I did that one with you. Okay, so what? No. Let's just double check. Some people are saying no. So for the 17 one, 16's there, 18's there, but no 17. So we knew the difference was 4. So what you do again, well, you know 16, you know 18, we can probably figure out 17. So here's the 16 and the 18 lines, those ones that I just highlighted, and a difference of 4. So if 16 was 9 and 18 was 11, what do you think 17 was? 10, yeah, so 8, 9, 10, 11. But what if we get one that's slightly bigger of a difference? Like, how about this one? If we were trying to find 25 as a dry bulb and a difference of 6, how do we figure out that one? What's halfway between 14 and 17? I see some wheels turning. I'm going to show you how I do it because I'm like to make things easier than ever. I do 14, 15, 16, 17. I truly write it out. Now that I wrote it out, like you said, 50, halfway is right there, which is 15.5. I truly have to write out there, look, I did another one there. I don't remember what numbers those were. But again, I had to write it out. I cannot, I'm sure there's a way to do it. You technically add them up, divide by 2, but it's just easier to do it that way for me. Okay? So that was last night's homework. We need to flip back. So we talked about temperature, but let's go back to that very front page about temperature. And there is a concept that we've talked about over and over again, but I'm not sure we've ever completely like actually wrote the notes for it. And that's at the very bottom of the front cover. Heating and cooling of air by expansion and compression. We have talked about this over and over again. Guys, what does warm air do? It rises. Warm air rises, like a hot air balloon. Warm air rises. What's cold air do? Sinks. Now, when those warm air molecules, why do they rise? I guess is what I want to talk about.
That's just less water vapor.
No, that's not it.
Oh.
What do those warm air molecules do so they don't, what would you do if you were all hot and sweaty?
What's up?
You spread out. You spread out when you're all hot and sweaty. That's called expansion. Now, once that warm air has spread out, what's going to happen to those air molecules? They're all spread out. They rose into the air. If you were hot and sweaty and you were spread out from all of your people around you, what would eventually happen to you? You'd cool off. Okay. Now let's go the reverse. You're freezing cold. What do?
Get together.
You get together, you huddle together. And once you're huddled together, that's called compression. We're compressing you into one spot. Once you're all compressed into one giant pile, what's going to happen to you? You're going to start to warm up. That is called heating and cooling of air by expansion and compression. When gas expands, its temperature will decrease. Those hot, sweaty molecules will eventually cool off. So what really happens is warm air rises, it expands, and then the temperature decreases. Then the reverse is true. When it's cold, it compresses. That's going to cause the temperature to go up. When cold air sinks, it's compressed, and then those molecules get warm again. It's what causes that repetitive convection current. When they get to the top, they expand and cool down. You already did the spinny thing?
Yeah.
No, some people just need to wrap that up. So no new lab on Monday. Same with tomorrow. Everybody's done it. Or everybody was there, or anybody, oh my gosh, we're finishing up the lab tomorrow.
That's kind of
It was a point. A little more fun than others too.
that thing's warm and kind of fast. Or the morning.
You're good. This was a big slide. No need to rush. That was the only thing that I had skipped over that I thought was super important for right now. Now what I want to do is kind of pull everything we've talked about, including this one right here, together. None of you guys were just in lab. I just had a group that was, oh, none of you were in lab. Did you guys do the spinny thing?
Yes. Yeah.
Were you just out there? What'd you get as your relative humidity? Do you remember for your outside one? So do you remember what the actual humidity was, or did you? You didn't get that far. Perfect. So a couple of my kids did. They didn't all, not everybody got to doing the chart yet, this today. But I had two people who were out there and did everything, and they got, so Katz was close, they got 10 and 10 as their numbers. So when you throw 10 and 10 onto your reference table to get the relative humidity, in fact, why don't you guys do that right now? 10 was the relative, it was the dry bulb. 10 was the wet bulb. Wait. 10 was the dry bulb. 10 was the wet bulb. What numbers do we use on our reference table? Why 0? That's the difference. We don't want 10 and 10. We want 10 and 0. What's the relative humidity? 100%. Guys, what does it mean when the relative humidity is 100%? Oh, yeah, that is what it means, no doubt. What's that mean? It could mean it's gross. Now, we did talk about this yesterday and you missed it because you were out celebrating your birthday. Do we feel gross when we go out there right now today? No, and do you guys remember why 100% humidity today does not feel as gross as 100% humidity on a warm day? Why does it feel less gross today than it does in August? That's not, because it's colder today. And what do we need? Why does it being colder today mean that it feels less gross today? Because cold air does not hold as much water as warm air. Guys, flip your packet to the back. I decided we're going to keep a running list of need to know facts. Because this is something that people are not remembering all the time. So we're going to make a list of need to know facts. And that one need to know fact is warm air can hold more water than cold air. That is one really need to know fact about this chapter. We've already talked about it multiple times. Mr. D legit has like the best representation for this. Here is a bottle that's representing warm air.
Oh.
Here is a bottle representing cold air. You guys remember when we were talking about this? Like, look at the size of the spaces in between you. Right now, you guys are warm air because there's huge spaces in between you that can hold water. So look at all that empty space that we could fill with water. Warm air expands. It's bigger, right? It's bigger, more room for water. Cold air, what do those molecules do? They pack together, so they take up less space. Now there's not as much room for that cold air, or for the water to be stuck in the cold air. It is Parmesan cheese, and I would have said cheese balls, but these appear to be animal crackers.
Oh.
Cheese balls are way better.
So that is a false statement.
Oh,
That's what he needs to
I know, we can't trust his opinion on anything. So today, there was 100% humidity outside this morning when we were out there. Does that make sense? What does it mean that there's 100% humidity outside? There's as much water as that air can hold right now. So basically that cold air thing is all filled up with water right now. Now, why we don't feel gross like we do in the summer? Because see how much water cold air can hold and be 100%? See how much water warm air could hold? And that's why. It's literally less water in the air when it's cold out at 100% than when it's warm out at 100%. So, but I still want to go back to, does it make sense that it was 100% humidity earlier this morning?
Yeah.
What happens at 100% humidity? What? Dew or rain or snow, moisture. That's another need to know fact. When the relative humidity is 100%, moisture is coming out of the air. Coming out of the air as dew or rain or snow. Can you guys think of any other forms of moisture coming out of the air?
Hail.
Hail,
Earthquake. That's not.
sleet. There's one other big one that I want you to realize is still moisture coming out of the air. We got dew, rain, snow.
Tornado.
Starts with an F.
Frost.
Fortnite.
Frost is true as well. Not
Fog.
fog. Frost is not
Fog.
wrong, but the one I was going with is fog. Not frogs. Toads.
Toads.
I'm also gonna add clouds to the list. Wait, what'd you say? It's supposed to rain soon. So it's not currently raining right now. But it is supposed to rain soon. And Zach, what did you just say? Okay, so the fact that my students got 100% probably means our really cheap thermometers were not perfect, but we're getting there because it should have been a really high humidity.
96%.
There we go. A 96% humidity would be right now for real. Did you just get that off a WeatherBug or something, or?
Yep.
So it tells us right on WeatherBug. I don't know if mine will show it. We'll see when it pops up again. 96% humidity. What does that mean that the humidity is so high? That's not what it means.
That's not even close.
It's not close, but what does it truly mean that the humidity is 96%? Do you catch? So you see it? Humidity, does it say 99 there? Okay, that one says 99. Well, I'm not sure which one's real time. That's actually the dilemma. So I think this is something we need to write down because no one's answering me.
What's up?
The higher the humidity, what does that mean? As humidity goes up, what else is happening? What can I say? The higher the humidity? No. What's gonna happen? Because the humidity is 99%.
Start doing something.
It's gonna start doing something. What do you mean by something? Yeah, one of these guys. Yeah. The higher the humidity,
The more chance.
there we go. The higher the chance of precipitation. It's not quite the same. It's a concept that revolves around the same concept. You're right. Yes, 100% humidity, it is precipitating. That's the point. The closer we get to 100, the closer we get to those precipitations happening.
If you're telling me it only snows, rains and all that stuff when it's 100%.
I am. That is the moral of the story.
That's a good story.
So then why is it if like you look on your thing and like it doesn't?
So when it rains, it pours.
Maybe it does, maybe I just don't pay attention.
Well, that and our instruments are not 100% accurate. That is also a problem. It could also be 100% humidity higher up in the atmosphere. Maybe not quite 100 down here on the surface, but it's raining higher up and that rain gravity, so it does have to eventually just hit the ground. Okay, and then the last thing I want to talk about is dew point. We were talking about dew point yesterday. What is dew point? We know how to find it now.
Something has to do with rain, I forgot, but I know it is.
It does. Okay. Oh, we don't remember, so we're flipping back. Love it, people. Love it.
It rains, it pours.
The temperature at which water comes out of the air.
Oh, okay. I thought you Googled it and I was gonna beat you, but no, we just looked at your notes, but your notes are on your phone right now. Okay. Dew point is the temperature at which the water comes out of the air. So if you recall, and maybe you didn't notice this, I'm not sure I specifically pointed it out. These dew points on the reference table, I'm gonna put them right here so everybody can see them. These dew points, these numbers, all of them, degrees Celsius. These are actual temperature. So when the air temperature hits the dew point, water comes out of the air. So right now it's about 54 degrees outside.
Really?
Yep, I'm reading my thermometer. So if it's 54, oh, it's not. Okay, I don't know why mine says 54. It's 47 outside. Did you happen to notice the dew point? Okay,
What was it?
46. 47 degrees outside. The dew point is 46. What does that mean? Say it again. If the temperature drops 1 more degree to 46, it means that it's going to start to rain.
Oh.
That's what, and does that make sense? That we're also 99% humidity? Our
Yeah.
fourth need to know fact that we've already learned since Tuesday.
Oh, we already learned.
Yeah, we learned this. You just had to put the 2 pieces together. You already had all the information.
Kind of like a puzzle.
Sure.
Please, John.
When temperature and dew point are the same. What happens when temperature and dew point are the same?
And then,
It will be very humid. So, but precip, are you guys good if I abbreviate precip? If you're not, spell it out. Okay, well then you spell it out, Jeff.
Okay.
So precipitation is happening. And if precipitation is happening, what's the relative humidity?
100.
And guys, we've only been in this packet for 4 days. No, 3 days. Tuesday, Wednesday, and now today. And we already have 4 very important need to know facts about this chapter. These 4 things pop up about this chapter more than anything else we're gonna do in this chapter, I think. One new concept I wanna do. It's pretty quick for today. We're going back to the beginning of the packet, page 25, and we're gonna start with air pressure. We had, what? Yeah, so this is the one little thing that I wanted to get done, today, for real. We've talked about this before. What is pressure? Just pressure, not air pressure. How about this? If I told you to put pressure on your arm, what would you do?
You look at it.
And
Press down,
you press down, you grab, you squeeze, but the key is that pressure is pushing down. So what do we think air pressure is? So if just plain old pressure is pushing down on your arm, what's air pressure? It's truly the air pushing down on you. It's not wind. Wind has to do with pressure, but it's not wind. Do you guys feel super strong right now?
Yeah.
Good. You'll swelled. Swole, what is it?
Swole.
There you go. You guys, I mean, it's pretty jacked here. Do you guys know that on every square inch of your body, does that air feel very heavy?
Yes.
Some days it feels heavier than others. Guys, on every square inch of your body, there is 14.7 pounds pushing down on you just from the air, on average.
Really?
14.7 on every square inch of your body.
Whoa. 6'5", 245.
So you guys are jacked. Even if you didn't know it, you're all jacked because 14.7 pounds on every square inch of your body, that's a lot of pounds pushing down on you.
Not really.
It really is.
Yeah.
14.7 pounds is the size of a bowling ball, a bowling ball weight
Yeah, but
on just every square inch of your body. Where's that weight coming from?
yeah.
The air. Now, did you know that air weighed anything?
I don't know,
Yeah.
gravity or something.
It's not gravity, it is the weight of the air. Now, weight is gravity pulling down on a mass, but you didn't know the air had a mass. But remember, it goes up, what did we say? 600 kilometers into the air. That's a lot of air molecules on top of you. Stack those up, it's like putting a bunch of weight right on your body. So air pressure, let's get this in. Okay, we only have 6 minutes, so we kinda gotta, I'm gonna probably skip through some of these. And of course, this is not cooperating.
Alright, not funny. When it rains, it pours.
It's supposed to rain and pour today, for the record.
What? It's supposed to like Saturday.
Sorry, I got lost here. Air pressure, right at the top of page 25, is the weight of the Earth's atmosphere. It does change depending on temperature. How can the amount of air pushing down on you change depending on temperature? Yeah, because
That's how the world works.
what, we already talked about this at the beginning of class. What does cold air do? Cold air stinks. Okay, if I'm air and I'm cold air that's sinking, what's it gonna do to catch shoulder here? No, I'm not lava this time, I'm air. Okay, I am pushing down on catch shoulder. I'm here and I'm sinking, I'm going down.
Wait,
What?
wait,
No, I gotta keep going. We don't have time to wait. You have an actual question.
no, wait.
Oh, wait, yes. Whoa. Oh. Now I feel like a fool. Cold air stinks like a weight on cat's shoulder. Absolutely. Anytime something's pushing down, even if it's air that's going down, it's gonna weigh down cat's shoulder. And she's gonna have more pressure on her shoulder. Now, what does warm air do? Heat rises. Yeah, so instead of that weight pushing down on cat's shoulder, what's gonna happen to the weight on cat's shoulder? It's gonna be pulled up, and then how would cat's shoulder feel?
Not that good.
Not that heavy. It's gonna feel less pressure on it. So the pressure will change depending on whether it is cold temperatures or warm temperatures. We use what's called a barometer to measure this. And is it raining?
Oh my
Oh,
God, it's raining.
So guys, what's the humidity outside right now? 100%. What? My thing's all messed up. And what's the dew point? Well, the actual temperature is 47. That must be lagging. The actual temperature is 47. What must the dew point be right now? 47. And again, my machine must be lagging a little bit. Did you write this, guys? We use a barometer to measure air pressure. Guys, one question that will be on the regions, I'm not sure which one it is because I'm not in charge, but there's always one every year. Is they're going to talk about weather instruments. Whether it's a thermometer, a sling psychrometer, or a barometer, or when we get to wind, those instruments. Every year they talk about a weather instrument at least once. So you do need to commit these to memory. Air pressure is measured in inches of mercury or millibars. And once you write those two, please flip your reference table to page 13. I want to do the very last thing we're going to do today.
Yeah.
Nope.
What?
Okay, so grab page 13 of your reference table once you write inches of mercury and millibars. Just like with temperature, and here's where you might want your larger blown up version of the reference table. Just like with temperature, like we did the other day, you will have to convert back and forth between Fahrenheit, Celsius, and Kelvin, and now millibars and inches of mercury. It's right there on the right side of the graph. This graph chart works exactly the same way as the temperature one. So you find whichever one you know. So if you had millibars, you find that millibars and you read the inches of mercury. The only thing weird here is now again, what are those temperatures going, or those numbers going up by? Mrs. Ritz? Yep. Okay, bye. All right, so what are the labeled lines? The labeled lines go up by 4s. That's awkward. For example, here's 1036, 1040. What are those little lines that are unlabeled?
37, 38, 39.
Yep, 37, 38, 39, 40 is labeled. So that side is going up by 1. Notice I labeled it.
Oh, I didn't figure that out.
What's this side going up by? We have 30.6 and 30.7. 0.01. So here's here's 30.60, here's 30.61, 0.62, 0.63, 0.64, 0.65. So this side's going up by 0.01. You're going to practice with all the stuff we've learned so far tomorrow, okay? Why don't they do pressure what?